Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, we sit down with Jordan Tigani. Jordan is currently working on a startup centered around DuckDB, a new in-process analytical database, and he was formerly the engineering and product lead for BigQuery. This was a fun episode because Jordan has such a breadth and depth of experience building databases. We talk about big data, small data, the promise of WebAssembly, HTAP, data apps, and more. This was a mind-bender episode for me because as it got me thinking about where we've come and where we're headed with database technologies, Jordan certainly knows a whole lot.
Mind-bender for sure. And it was also, if you've ever talked to anybody who is a big fan of DuckDB, it becomes this almost zealous company, they're a convert. They've seen the light. They want to tell you about DuckDB and they're not going to go away until you've seen the light too. And it's such an interesting product because we imagine our databases as living somewhere else. And we communicate with them via these reasonably thin pipes over the network. And then DuckDB sits in process. And then the question becomes what can you do with that? And Jordan is right at the center of this ecosystem and I feel like we only scratched the surface of the potential implications of this technology.
Totally. It's hard to see the future always, but it's the right kind of questions that follow from, wow, if DuckDB becomes possible, what then? What next? What does that enable? So this was fun for me.
I don't think anyone exactly knows the answer to that question, but...
Oh, good, because I don't, yeah.
It's clearly a productive question to be asking.
Yeah, it's definitely a building block to maybe an interesting future that we can't fully visualize yet. So without further ado, let's get into it.
Jordan, thanks so much for joining us.
Yeah, thanks so much for having me. I'm looking forward to the conversation.
I did a little stalking on your background before. You and I have hung out a couple times before, but I actually didn't realize you have been doing distributed systems work for much longer than it has been cool. Yeah, the first decade of your career, I was looking at your LinkedIn profile. It says managing fleets of machines and detecting race conditions right from the beginning of your career. How did you get into doing that type of work?
I was in Microsoft Windows, and I was working on the kind of the kernel team and looking at some of the sort of interesting scalability things, and ended up on the deployment team. And then sort of how do you manage to deploy sort of to a whole data center of computers, and then also sort of ended up moving into research because there was a research team that we were working with, and then they seemed to be doing some cool stuff, and so I switched over to there. And then the odd thing was then I got reorged back into Windows, I think because the research team was doing something that was too useful. It was, Microsoft research with that at the time, that was sort of a no-no. You don't want to actually, have anything that you're doing actually ship in a product.
I have to imagine that you don't just happen to find yourself on the kernel team in Windows at the height of Microsoft's dominance. Did you try like hell to get involved in that project?
No, I was, I guess I was an electrical engineering major, and that seemed sort of like an obvious thing to do. I liked not having black boxes beneath what you're doing. So kind of you kind of start from understanding how the hardware works. And then you start at the kind of at the kernel level. And I think it's a good way to start your career because then you kind of know what's going on underneath. And actually then when I moved into research, it was more of a compiler team and sort of kind of understanding the compilers and sort of, it took me a while to actually figure out, how stuff actually worked. And then I could sort of go on to sort of some higher level stuff from there.
So when you talk to new software engineers today, you tell them start your career working on kernels. That's
assembly. If you can't do assembly, then you shouldn't be a coder. No, I'm totally kidding. There's some people that like to understand how stuff works, and some people are like, whatever, I don't care about that. I'm just going to handle that all of that as an abstraction. And it really only comes into play when you really need to get the most performance out of something, or you need to get the most scalability out of something, or reliability. Then you're like, well, there's this, in order to make this really work, we have to do X, Y, and Z. or in order to make it really fast, like you really need to understand, like, okay, well, this is what a hash table object in Java actually represents, and there's all these other pointers involved in it, and it allocates this much data, and so that kind of stuff can be useful.
I'm going to keep pulling on the same thread. So we're going to get to your experience at Google and BigQuery, but just before that, you had a job that reads like this, and this is in 2008. Wrote custom machine learning harnesses for determining personality attributes based on clickstream logs. That you were doing machine learning before machine learning was cool. Again, like, did your curiosity just like pull you in this direction?
So that was actually kind of funny. I got hired by the guy who had been the chief scientist at a company that I'd worked at before. And he was the only guy in the Seattle office, the only person in the Seattle office. And then he hired me as the second person. And so, and he built all the machine learning infrastructure. And so the day before I'm supposed to start, he calls me up and says, at 7 a.m. and says, by the way, I'm leaving this company. And so I had quit my previous job. I had signed on to work at this company. And he says, by the way, I'm leaving. And so now the Seattle office of one, which was going to be two. Now I was the only person in the Seattle office of this New York based ad tech company. And nobody else knew how the machine learning stack worked. And so I inherited, several thousand lines worth of R code, and not knowing R, and only knowing machine learning a little bit. Like I'd had a course in it, but then I had to figure out how to make this stuff work, and how to make it work kind of at scale, and to do some pretty interesting things. But I learned a ton doing that. And I think the other thing I learned that really carried me into sort of the next step at Google was that, they were doing clickstream logs, and they had a pixel on something like, I don't know, 10% of the internet. And so for every click of 10% of the internet, they're getting a log entry. And so this was like terabytes of data per day. And so like having to understand big data and big data processing, that was sort of my first exposure to that, and to sort of what an interesting problem that is to solve and to be able to do effectively. And so one of the reasons that I went to Google was because Google was really leading the way in handling these kinds of problems, which otherwise were kind of intractable. I think Hadoop was just becoming popular, but had a lot of drawbacks as well. And I think Google had, even at that time, had already started to move beyond Hadoop to some, MapReduce to some other alternatives.
Okay. The transition to Google makes sense, and the transition to BigQuery makes total sense given exactly what you just said. So that happened in 2009? Is that when you joined?
Something like that, yeah.
The roots of BigQuery are actually really interwoven into the Google story. Like, it was such a critical service for, internal service for such a long time. Can you tell a little bit of that history? Where did it come from?
Sure. There's actually kind of two histories. One is Dremel, which is the query engine that was, deeply, involved in Google and kind of so many teams at Google use Dremel. And then there's BigQuery, which is the cloud service.
Sure.
And so Dremel had been around for a couple of years, and, it started, I think somebody's 20% project. They were tired of their MapReduces taking so long. And so while their MapReduces were running, they kind of wrote this engine, that, column stores were sort of starting to become popular. So, he wrote a column store, and also, like, one of the real bizarre inefficiencies of how Google does things is they denormalize all their data. Like, they have one single clickstream data format, that has something like 7 million fields in it. And so it's all heavily denormalized, but it's all you can do it in a single scan, but is ideal for a column format, because if you can project and only read the fields that you care about, then you can only look at a very, very small portion of the data. So anyway, this guy Andrei Gubarev, he started Dremel. He had an intern, and the intern helped develop it, and it kind of started scaling from there. Internally at Google, there were half a dozen query engines that could do similar types of things. And Dremel was sort of the best of them. It was one way that I think Google, could sort of compete with other companies because there was also competition inside Google. It was sort of like, it wasn't just like, this is the anointed way to do data processing. It was like a bunch of different teams. They kind of built different things for what they were trying to do. And then the kind of the best one ended up winning, which was Dremel.
When you were hired to work on Dremel, an internal tool, or were you hired to create an externally facing thing like this?
So I was hired to actually work on Flume, which became Dataflow. I had like this like amazing fascination with stream processing systems. I just thought like it's just a much more natural way of handling data. And once you sort of wrap your head around kind of a stream rather than kind of a batch of data or kind of an imperative model, then like a lot of things just end up working really well at scale. At one point, I watched some old videos of so it's MIT class, a structure and interpretation of computer programs, and I think like the videos, like the hairstyles and stuff, are like 1985 or something. And they're writing code in Lisp, and like it shows in Lisp this like amazing kind of a problem you never thought you would solve with stream processing, and he kind of solves it in a streaming way, and it just sort of broke my brain, and I'm like, wow, like streams, like we should be using streams in more things, and so that's what I wanted to work on, which was internally it was called Flume, now it's called Dataflow. I was working on that for a few months actually, and then the site director pulled me off of it with a couple of other people and said, this is Brian Bershad, and I just want to give him a shout out because he is really the person that created Google Cloud. He doesn't really get any credit for it, but he created BigQuery, Google Compute Engine, Google Cloud Storage, the sort of the Dataflow team, and there was all like a very small team in the Seattle office. Like we all shared one floor. We thought it was getting huge when we took up a whole floor of one small building.
That's so fascinating. GCP came out of Seattle, not out of Menlo Park or the San Francisco area.
And I think because at the time, a lot of people at Google thought we shouldn't be building infrastructure as a service. That like, we're Google, we want to build higher level services. A la App Engine sort of was the other. So App Engine was out of Mountain View, and that was sort of seen as like, okay, this is the way we're going to do cloud. Who needs a VM? Like VMs are so passé. We don't even use VMs at Google. We should be giving people higher level services.
That's super interesting. So you leave the Flume team to go work on BigQuery, presumably. And I'm so curious about BigQuery because it's really good at a lot of different things. Like the first way I interacted with BigQuery was for a side project, and I could get up and running with just my Gmail. And I think I still pay like BigQuery. I think my bill is like 4 cents a month, like something insanely low, just to power a really small script that I run into BigQuery, and it powers a dashboard for me for a side project. But it was like built initially for these like big distributed workloads, and part of the power of BigQuery is that you can have these like virtual CPUs and run slots all processing your data, really big data efficiently. And you would think that like maybe those two things might be at odds, like really easy setup for a side project and also being able to process enormous amounts of data quickly. What was the like origin story? Which were you better at first? Did you have to get really good at the other muscle over time? I'm just curious how that evolved.
At the time, it was during the sort of the era where there was sort of the big data was the big buzzword of the day, and so we wanted to make sure that BigQuery worked really well for big data, and that's what we saw as the goal. That's why it was called BigQuery. I think it had separation of storage and compute. It was serverless. Had a lot of things that sort of became popular pretty much later. But the question about like what size we were targeting, like we knew that we wanted it to work on very large size data sets, and that was what we mostly advertised. But we also wanted it to work on smaller data sets as well. I used to call it any size data, because really it should be, it's really, data size independent, how well it actually works. And, for a long time, your queries would return in a couple seconds, whether it was, 100 terabytes or 100 megabytes. Is sort of everything took kind of the same amount of time. But if a lot of people have, all large data sets start out as small data sets, and they're generally, pretty much all large data sets are generated over time. And, we wanted to get people in when their data sets were small. And then, some of those data sets are gonna grow much larger. And I think it was surprising to us how many people had small data and continued to use small data. I mean, we loved having those users, and some of the most like kind of outspoken proponents of BigQuery were people that, like, there was one guy, he'd brag like, I spend only $4 on BigQuery a month and I get all of this value out of it. Yeah. If you're only spending 4 cents a month, like that's amazing. And so I think that's actually super exciting to me, and kind of has remained one of the things that I've been fascinated about, which is sort of like, so if BigQuery was really kind of, you can think of it as two products. It was BigQuery for crunching the giant data sets, but it was also kind of easy query. It's just sort of, you walk up to it, you load your CSV file and you run your queries, and like you don't have to pay a whole lot of money. And I think that, as the industry evolved, I think the BigQuery was sort of emulated, or at least, has shown up other times, and there's other people that are doing, large scale data processing and parallel data processing. But I don't really think anybody has done easy query. And that's, sort of surprising to me. I mean, Athena sort of is trying to do something similar. But other than that, like, I don't think anybody is really building this sort of just like, walk up and run your query, something that's always running, but you only, are always available, but you only kind of pay for what you run.
And I just have to ask, because, it's the things that we think about too at DBT. Like, we want to have DBT be easy DBT, have everyone be able to use DBT. But then we also have this like spectrum of users where we have really large enterprises using our products as well. Do you think that everyone will have a data warehouse? Do you think that it will become just like your market is endless, where everyone should have some kind of data warehouse to do any number of things? Because I still encounter people that don't have data warehouses, where I feel like, you mean what? How do you do anything without having first put your data in a cloud data warehouse? Do you think it will be pretty universal?
I believe so. And I think, I guess one of the ways I like to think about it is, there was the mainframe era, and then there was the personal computer era that sort of democratized access to like computing power. And in the mainframe era, everybody had to share one giant box, and like, a lot of the energy was involved in sort of like, how do we partition users and how do we make it work for everybody? And then the personal computer era was just so much more flexible, and kind of everybody has access to it, and it's easier to use. And I think it's the same thing with like sort of the enterprise data warehouse is this big box that kind of everybody had to share, and like workload management was incredibly complicated, and permissions, et cetera, who gets to do what. I think that there is going to be, and there is emerging a kind of a personal data warehouse era where kind of everybody gets their own data warehouse, and everybody can do data warehousing on their own.
Personal data warehouse. It sounds very Microsoft of 1985.
Perhaps. Maybe we need
data
a
warehouse
better
for every desk.
True, but at least, like when you talk about enterprise data warehouses these days, like I think that's one of the reasons that everybody is kind of going away from the term data warehouse, is because it sounds sort of like, it sounds like kind of old school data warehouse, like, back when everybody wore white starched shirts and pocket protectors, and now it's sort of data platform. But I sort of resist some of that terminology, just because data platform it's kind of meaningless.
It's not super specific about, you could imagine that being a very large number of things.
Yes. I mean, how many companies, say they have a data platform, and I'm not criticizing them, but it's just like, they can do lots of totally different things. And if you want to say, well, what is it? Data warehouse at least is like you can understand what it does.
For now, I think that it's changing quite rapidly, and that's another part that I'm super interested in. It's like BigQuery was designed to be really interoperable with lots of other parts of the GCP app ecosystem. Like, you can integrate your BigQuery warehouse with Google Sheets, and you can integrate it with Looker, and they have like
serverless Spark.
Yeah, there's just like, it ends up, it's a database really. And, we had this conversation as well when we had Aaron on from ClickHouse. He's like, well, ClickHouse can do so many things. It's a database. So your imagination is, let it run wild, and ClickHouse can do lots of those things well. But BigQuery was also kind of really built with native integrations to other services in the Google suite. What do you think the boundaries are of what a warehouse should or should not do? And are there places where you'd say, BigQuery is not good for that use case?
When BigQuery was started, I don't think any of the people working on it, or almost any of the people working on it, there were a couple, so I will, but most people working on it didn't have any idea what a data warehouse was or why it was interesting. And if you said we were going to build a data warehouse, they would have said, all right, I'm going to change teams. I'm going to go work on something else because I don't want to build a data warehouse. That sounds really dull. But I think then we built what we thought was useful and we thought was going to be good for users, and that there were a bunch of people like that internally at Google that were doing, we saw there was a need to process data and to query data, and to have something you can do with your data while it's in the cloud and not have to move your data, locally. And it was only a little bit later, several years later, in fact, that somebody said, if we just added a couple of features, it would be a data warehouse, and we'd be able to sort of compete for data warehouse workloads. And we're like, oh yeah, that's a great idea. Data warehouse, there's a lot of people, there's a lot of opportunity here. But I think we always thought of ourselves as something more than just a data warehouse. It was something. And I think what's interesting is that if you kind of draw a Venn diagram of like kind of needs, the data needs are much more broad and encompassing and data processing needs are more encompassing than what is traditionally data warehouse. The box that you draw around data warehousing is really the box you draw around what the technological capabilities were 20 years ago. And so kind of when you break down some of the barriers to, that constrained what you could do in a data warehouse, separation of storage and compute, you're in the cloud, you can have virtual infinite compute power, and, sharing across users, you and organizations. Then it turns out that I think the need, goes further and is much broader than a data warehouse. I think, I gave a talk at Strata a few years ago called Data Warehousing is Not a Use Case. Is that like, you should kind of go from what the use case is, what people care about, and what people care about is actually a lot broader than sort of just data warehousing. But I think data warehousing is also just a nice shorthand for, hey, I have some data that I need to, I need to ask some questions of my data, and I want to display them in a chart or a report or something. Data warehousing is sort of a really nice kind of way of like understanding the system that's going to enable you to do that.
It was fascinating to watch your team go through some of these mental model shifts over the years. I remember using BigQuery in 2015 when I believe I still had to use, what was the name of the syntax that you had at the time?
Internally, it was called Dremel SQL. I think we called it, and then we ended up calling it Legacy SQL as opposed to Standard SQL.
Yeah. And then I was just like, oh my gosh, you're going to make me learn this other thing. And I did a little bit. And then Standard SQL came out, and you knew that like this had to be just that you just got to see the tip of the iceberg. And really, there were probably lots of battles internally about like the identity of this thing. And then, I remember having conversations with folks on your team where we were like, we need a create table like SQL statement. Like we need the DML, and it just like didn't exist. And over time, more and more of that stuff got built out. So you didn't have to like fire off RESTful API calls to do this. So it felt more and more data warehousey, and I'm using my fingers in air quotes here, over time. So it's clearly that conversation was going on internally.
And just in terms of like how much should be in SQL and how much shouldn't be in SQL, and what is standard SQL and what's the right way to do things in a database. There were lots of debates on that. I was the database like neophyte, or the database person. Like I was responsible for a lot of the stuff being in REST APIs rather than SQL, just because that's what I knew. I was like a distributed systems person, not a database person. And then we hired a bunch of database people, and then we ended up adding on the things that that are more common in databases. And I think that there's pros and cons to sort of both ways of doing things. On one hand, it's nice to be able to do something in SQL, but also it's also nice to be able to have like a control plane separated from the actual kind of query plane, and because there's often two different types of operations that you do. Certainly DML is not in that. I mean, DML you should absolutely have DML, but like if you're doing other kind of administrative tasks, like do they have to be in SQL?
Like user permissions?
Yes. Yeah.
Yeah.
Well, anyway, yeah. Yes. But like user permissions.
Yeah.
So I want to switch gears a little bit and talk about a different overloaded term, which is data apps. And, we had some time to talk before, Jordan, and we felt like people throw around the word data app, but no one really knows what they're talking about. But we had kind of similar definitions in that it allows a user to explore data maybe in a customer-facing application. And so it's moving beyond the analytical, like I need to understand my internal analytics, to in my production app, I'm going to expose some kind of analytics to an end user. I want to hear your thoughts on data apps and whether we need new technologies to power them, because traditionally, like production apps have their transactional databases. Analytical workflows are a bit different. Are we going to see them combining more to have both transactional and analytic workflows? What needs to happen in order for data apps to really become more mainstream?
So I think it's a great question. Just last night I was at a data council dinner, and I was talking to somebody, and there's like, yeah, I have a startup. This person was saying, I have a startup, and we're trying to handle data apps. And as he elaborated, is it's all about machine learning and kind of bringing machine learning to users. And I'm like, wow, that's not what I thought of as a data app. Like I thought of a data app was something else. And I think it's just, it's not that this person was wrong. It's not like, it's just that, it's a overloaded term that everybody kind of applies kind of what their lens is to it. My particular lens, and that comes from kind of what, some of the patterns that I've seen are, I think is best to summed up as somebody described it to me as like more and more services these days are collecting more and more data on behalf of their users, and they want to share that data with their users. And so sharing data with users, basically that means some sort of analytic. If you have more than a handful of fields, you want to be able to graph it and chart it and slice it and let people do drill downs. And I think that this is becoming more and more common, and I think some of the, it shows up in a bunch of different ways. And I think one problem around data apps is like somebody say, well, what's the kind of prototypical data app? And it's sort of hard to say what it is. It's just like but it shows up in so many different places. Like sort of an obvious one might be kind of, financial app where, everybody wants to kind of chart their portfolio or see like how various stocks have done over time. But like I was talking to somebody who was, they're doing kind of a web-based CI/CD, and they were doing, they want to show to their users, okay, well, how long does it take to do your builds? How many pull requests by how many bugs are found and how many unit tests and like all these things that people can slice and dice. Like that's analytics. And so the next part of your question was like, okay, well, do we have the tools that we need to handle that? And I think in general, the answer is no, or at least kind of the tools that we might think of first for using that are probably not the right set of tools. For example, I don't want to pick on snowflakes, but like BigQuery, for example, concurrency can be limited, and I think concurrency is limited because the hardware involved is limited, and in some cases, like so Snowflake lets you, when you get high concurrency, it lets you expand the hardware you use. Of course, you expand the hardware you use but that costs you a lot of money. Like if you end up having to spin up multiple warehouses, like you're setting money on fire at an ever increasing rate. And so I think in general, the kind of data warehousing systems are not really designed for the kind of concurrency that you would expect for a user-facing application. The first concurrency,
which is not surprising, right? You're going to make really different trade-offs.
Yes, absolutely. Because there's, concurrency and then latency is the other one. Like you have an end user facing application. End users are used to sort of, virtually instantaneous, experiences. And, I think people have, various studies have shown that for every 100 milliseconds of latency, like some of your users are just going to sort of get bored and go and do something else, or at least they have a measurably worse experience. So I do think you need different tools. The question is, should the analytic tool be the same as your operational or as your kind of your transactional database? That's certainly what, so I was at SingleStore, after Google and that's certainly what SingleStore we were trying to do. We were trying to say, hey, why have multiple databases when you could just have one databases? And I think that this is actually a use case where HTAP does make sense. I think HTAP is sort of for database people, HTAP is often seen as sort of the holy grail. It's like, oh, well, we can do everything in the same place. And in general, like trying to combine your transactions and analytics aren't necessarily it's not a burning problem. There's basically two different buyers for those. The application developer is generally in charge of selecting the application database, and then the analytics team, the data team, the CIO or the CDO or whatever, kind of is in charge of selecting the analytics stack. To try to sell one database to both of those people is going to be difficult. But I do think in the data app case where you have the one, low latency database that, you can do transactions on, you can do analytics on, certainly makes it easier, especially if so that way you can do the analytics on the latest data. Cause that's sort of the other tricky part is users are expecting, hey, they make a change, they do something that, they do something different. Then that shows up in your analytics. In Strava, if you go for a run and you want to see like your fastest run times or the fastest people on a certain segment, you want that run to show up there. And if it doesn't, you're going to be annoyed. I think there's other kind of interesting things where you can do, which is, and I think this may be sort of getting back to sort of this personal data warehouse idea, and maybe that is to 1985. But the, if you can have, because one thing that often is useful, especially in a data app, is you really have each one of the end users of the data app kind of has a separate segmented data set, and all of their data should be, all of their queries, all of their operations should be over that subset of the data set. And so what you often see is people like, we talked to somebody who was running like 10,000 RDS instances so that they could, basically each one of their users got a separate RDS instance. And so what they, and in general, that's kind of prohibitively expensive. And so what they'll often do is they'll run one big RDS instance or one big database. And then, for their largest customer, and then they have like a long tail of small customers. And each one of those customers, or actually those customers get bin packed into kind of another subset of instances. And that's a lot of work. It's a lot of manual work. Like I think there's sort of an opportunity to give people something that, that basically can scale to the numbers of users they have and give each one of them kind of an isolated environment that scales to the size of those users.
I feel like the number of times that it would have been entirely appropriate to say the word DuckDB at this conversation is like excessive. Like we missed so many different transitions. Julia, do you want to take us there?
It's time. Yes. What technology are you excited about that might help solve this kind of a problem? And does it rhyme with,
I don't know, what does it rhyme with, Julia? So yes, there is a one that rhymes with the F word. DuckDB is for those who aren't familiar with it, it's a database created by some folks in the Netherlands, out of CWI. It's a government lab, and I think they wanted a good academic platform to build sort of analytics on top of. And there wasn't a great one. There was a couple of existing ones that had kind of old and crufty code bases, so the Hannes, the one of the founders, kind of he had just gotten tenure, so nobody could tell him what to do. And, had one of his students who had just gotten, finished all of his papers for his PhD, but had some time left. And so they're like, all right, let's just build something. And they turned out to be amazing coders, which also, sometimes isn't the case with academics who just, they write something to prove a point, and they wanted to build something right. And so they built this really clean system. It's very fast. It's a modern code base, has lots of extensibility points. It's getting more and more adoption. It's got something 150,000 downloads a month. And
what's it written in?
It's written in C++.
Okay.
And, but it's written in sort of modern, C++, 11, C++ with, safe pointers and all the good stuff, and, uses arrow to move data around. So it's got some really nice features, and it's incredibly lightweight. And so it, one of the way they have zero dependencies. So even the Parquet reader, they rewrote the Parquet reader themselves so that it could have no dependencies. And one of the advantages of the no dependencies is that it can run in WASM in the browser.
Do you want to spend a little bit of time describing what WebAssembly is? I think it's probably a new term for a lot of our listeners, but it's this exciting trend that we've all been following too.
Yeah, sure. So, WebAssembly is, this technology was, I guess originally designed to be able to run random stuff in the browser. And they, by basically, kind of compiling it down to, or sort of running a virtual machine, it's been built really well so that it, you can get almost near real time, near bare metal performance on it. Or at least that it, that's the goal. It'll eventually get there, and it's trending that direction. But you can really run almost anything in the browser. And then it actually turned out to be useful for other cases as well. So there's, in SingleStore, they're using it to, they're running it server side, in the database. So you can, you can run any arbitrary code in the database. Like some databases have, JavaScript, like BigQuery had JavaScript, like, other people are doing sort of Python. And it's sort of easier to do some of these, heavily interpreted languages, but it's quite hard to do it so you could run, virtually any machine code, C++ code, and do it in a way that is both performant and secure. Security is obviously is quite tricky. There's some things that in WebAssembly that are still kind of being figured out, like sort of what's the right way to access data and, pipe data through it. But it's, I think there's a lot of really smart people working on it, and I think it's really compelling in a way of being able to sandbox computations. And I expected to see it showing up in all sorts of interesting places in the future.
I think one of the more exciting WASM experiences that a lot of us have probably interacted with is Figma. You feel like you are using Figma in the browser, but really it's your computer that's doing all the processing, and it will work on the design file. So it feels really real time, and you don't have to make calls to an application server, which would be too low latency. But it's hard to do with databases, right? We have kind of SQLite is the transactional version of it that runs really well browser side, but there's not a good complementary analytical database that can do it browser side. And this is kind of the promise of DuckDB, which is it runs on a single node, and you can unlock all these kind of new experiences that might have been hard to do without the technology.
Absolutely. And I think, in BigQuery, one of the kind of the mantras that we had was, when data is big, you want to move the compute to the data rather than the data to the compute. And that drove a lot of design decisions that we had. But one of the things that it turns out is that, and I think as you were mentioning, you use BigQuery, but have relatively small data sizes. Most people don't actually have big data. Most people's data set sizes would actually fit on a single machine. By default in BigQuery, you get 2,000 cores and 2,000 slots, and which is a lot. And 99.9% of BigQuery users, basically everything fits for the 2,000 slots. But it's about $500,000 worth of BigQuery a year, and so that all that computing power could fit on a single machine. So like kind of everybody kind of looks at, scale out databases or scale up databases and like, oh, that's so old school. And like, and all the cool kids are doing scale out these days. But it turns out that you really don't need scale out. And when you do scale out, it just adds so much more complexity. It adds latency. It adds like all sorts of things that you have to do that make your life so much harder. Whereas, if you in scale up, you can make something much, much simpler. And I think DuckDB is a great example of how you can have a really fast, really robust, analytics system in a single node.
When you're saying fit on a machine, there's machines like the MacBook that I'm recording this on, and then there's rather different machines. What do you mean when you say fit on a machine?
Great question. So you can spin up a virtual machine on AWS that can have 24 terabytes of RAM and it has 450 cores. You can just spin that up and, you use it in.
So when you say 2,000 slots, you're talking about like a beefy machine, kind of like that.
Yes. And I think, but that's like $500,000 worth of BigQuery, the equivalent of $500,000 of BigQuery a year. I think for what most people are doing, you can do on your laptop. And the other interesting thing is that, especially, with WebAssembly is sort of the opposite of what we said with BigQuery is, in large data, you want to move the compute to the data. But if the data is small, you can move the data to the user, to the end user. Mm-hmm. And so, Julia, you were saying that, Figma feels like it's super snappy, and you could never be this snappy if you had to make calls back to the, back to the cloud side. So, you basically can, I think this is one way, getting back to the data apps, one way of being able to hit the high concurrency and that the data apps need is if you can push the data out to the user, then you can use the user's own compute. Like, Tristan, you mentioned you have like a fancy M1 Mac. I guess you're old school. You don't have the new M2 that they just released last week or whatever. But that has an incredible amount of computing power. And, so why not leverage the user's own compute to be able to do this? And just as an example, I saw there was a researcher at Carnegie Mellon. He has like this project he was working on that can do, they were like 6 linked dashboards or a dashboard with 6 linked graphs. And they could do basically filtering, brush filtering and drill downs and linked, these linked graphs at 60 frames per second. You can't do anything close to that if you have to have a round trip involved. So there's a lot of really kind of cool things you can do once you start to push stuff out to the browser. And having a full-fledged database in the browser just means that, because a lot of times what people do is they will pull the data down pull the data locally, and then they'll have to sort of like invent their own, essentially query engine or
right, like Tableau, or I think ThoughtSpot has a similar. Like there are many BI tools. I think Sisense has one that have some version of like a local caching engine to speed up those interactive response times.
Yes, yeah, absolutely. And I mean, because it is important to be able to do, but it often involves sort of a kind of a loading process. And I think if you can, there's some, because there are also some cool things that you can do, and where you basically can have a database that straddles local and the cloud, and you can have a query that actually runs across both of those. And it's a query optimization problem, and a query planning problem to figure out what data needs to be where and what parts of the query need to run where. So if you're doing a join, like some of the data is local, some of the data is in the cloud, it's and you have a cost model for how expensive it is to move data up and down. You can figure out, do I need to move the local data up, or do I move just sort of a Bloom filter up to like with the join keys, or do I move the other data down? Do I do project? What should I do? Like, you can do some really interesting stuff across local and cloud if you kind of can connect those things together.
Can I get you to do some translation for a second to the analytics engineering community? So
sure.
I think there's been, for some of our like most advanced users, there's been a lot of interest and love for DuckDB on Twitter, which is where all interest stems from. But here's the use case that I'm really excited about, and maybe I'm thinking small, but it seems very achievable that you could create a DBT distribution that actually comes with DuckDB and some seed data and a DBT project that uses that seed data on DuckDB. And so all of a sudden, step one is not like try to figure out how to, set up a tunnel to a remote Redshift connection or, what it's like. Your data's all right there. Your database is all right there. It's just like step one is DBT run. This is very achievable with DuckDB, right?
Oh yeah, of course. Yeah, absolutely.
All right. Well,
yeah, and you could do a lot with that, and you can, and I think it could scale. It can scale to a larger scale than most people expect. Like, I think it would be good to have a bridge to be able to jump from running everything locally to then doing things, somewhere else. But
again, maybe we're like queuing up all too obvious transitions, but like, is this local to cloud bridge what you're trying to solve in your commercialization efforts right now?
Yes, to a reasonably large extent. I mean, I'm working on a company called MotherDuck. It's related to DuckDB, and I don't want to go into it too much just because I don't want to be spewing vaporware and saying like, hey, we're going to solve all the world's problems, and then it comes out and people will be like, oh, well, that's not what I thought it was going to be. But I think the some of the things that it's going to handle are easy query, being able to do things in a very easy way, especially if you're not doing, working over massive data sets. And then one thing we absolutely do want to be able to handle is sort of the sort of local to cloud transition. And how do you can use the open source DuckDB locally. And then you can make the jump to cloud, and then you can even sort of do some stuff where you're sharing back and forth.
Yeah, I think that sounds really exciting. Like, that's the consistency piece that was logically I was trying to get to, is like, okay, I'm doing all this cool stuff on my own computer. That's amazing. But we have, my team needs to be able to look at the same stuff eventually. And so that's where the problems, I'm sure, get really hard.
I think that if this is listeners' first exposure to DuckDB, it actually breaks your brain a little bit. Okay, maybe application developers have been using SQLite for a little while, but for those of us in the data industry, we are really never using local resources to like query a data. Like, the database is always somewhere else. And that has been true for my entire 20-year career. And so the idea that like there is a database that exists locally, and what will the implications for that be? It's actually like not completely obvious. I asked you a question where I was like, this would be amazing if I could just distribute the database along with and you're like, yeah, of course you can do that. But so like, I think it will actually take a little while for us to wrap our heads around the implications here.
I think sometimes the best technology shifts happen when, there's some sort of shift. And then because of that shift, it just opens up all these other doors. It's sort of like you knock down this one wall and then there's all this stuff beyond that wall that like, it takes you a while to explore. And it takes cause then there's things like secure computing, being able to do, to run queries without over encrypted data, without having to share the key. There's there's just a bunch of like kind of really interesting scenarios that you can start to think about once you have a full-fledged database that can run anywhere.
Totally. We'll have to have you back on the show once you've figured out some of these questions. You can tell us more about what MotherDuck is doing to solve these problems. But we ask this to all our guests. It's our wrap-up question. But looking 10 years out, what do you hope will be true for the data industry?
So what I hope will be true is that we can get rid of files. Like, I think that there's too many people using CSV files, first of all. And I think people are starting to move to Parquet at least a little bit. And Parquet at least has, self-describing schemas and you can do better, better types of analytics over it, in a much faster and more compact way. But I would love to see if the level of abstraction layer was raised. So instead of having to people having to think about files and how many files is this broken into and how's it managed, people just thought about tables. And I think that there's a lot of advantages from thinking about tables from a security perspective. Like, you can do column level access controls, even row level access controls when you don't require physical access to files. And I just think that as from a user perspective, like they should think about things in terms of like, tables and schemas rather than like, where did I put this stupid Parquet file, and why is there this one thing that doesn't match the schema, and it's just, I think, a cleaner mechanism. And at BigQuery, that was one of the things that was sort of my personal goal, was to sort of abolish the usage of files. I have not yet succeeded, but I'm hoping that somebody will succeed in the next 10 years or so.
It is kind of unthinkable. The beginning of my career was spent in the world of transactional databases. And when you're building applications, you're never writing to files. I mean,
Sure.
Virtually never. And then to come into the analytics world, and people were like hand managing the directory structure of Parquet files, you're just like, oh, we've really stepped backwards in time here. So glad you're preaching.
Thank you.
Jordan, thanks so much for joining us. This has been a tremendous amount of fun. Where can folks find out more about what you're working on?
So LinkedIn is great, or Twitter. My Twitter handle is just my name with all the vowels removed. Feel free to reach out if anybody's interested.
Thanks again. It's been fun.
Thank you.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.